And welcome to the 7th grade science unit 1 virtual preview. This unit is called Scientific Inquiry and Force. My name is Ann Lawrence and I am the 7th grade CTL for science. Since this is for unit 1, it's important to go over what a virtual unit plan is in general. So I want you to keep this situation in mind. Let's say that you receive a whole bunch of puzzle pieces face down. Those puzzle pieces could represent things like assessments, practice questions, activities. Option number 2 is that you receive all the pieces, but now they're right side up. So you have someone who provides you with all of those resources like tests and problems and activities, but now you have someone to explain their relevance and how they might fit together. The last situation is if someone like me, the CTL, were to provide you the end goal as well. So I want you to think of the virtual unit plan to be helping you by use of giving you the end goal or the picture on the front of a puzzle piece box, what your unit should look like for your students. So I'm going to provide you all of the resources in a separate place on Blackboard, and then to try to give you the end goal, this is what the unit preview is for. So the purpose of this is to act like the box of a puzzle, to give you an idea of what your students should know and what they should have experienced throughout the unit. That being said, we have a pretty lengthy agenda. The first thing we're going to go over is how CA number 1 has changed from last year and how that might affect Unit 1. I'm going to go over the order of objectives, common misconceptions about work and common misconceptions about scientific investigation design or the steps of the scientific method. And then I'm going to go over the 3 major labs in this unit, what you need for it and how they work. And then lastly, we're going to end with the true end goals of Unit 1. So let's start with the changes that have been made to CA number 1 and how that affects the first unit. If you pull up the document for the multiple choice section of CA number 1, you'll notice that a lot of the questions from last year have been eliminated, and the only thing that remains are 10 multiple choice questions, a majority of which are on cells and work. In Unit 1, the only thing that we focus on is the steps of the scientific method and work. In the multiple choice section, it's only work, no scientific method at all. So we have to put a little bit more emphasis than we did last year on being able to calculate work. As you'll see here in the 4 example questions I pulled from that multiple choice section, there are situations where people, 3 different people are doing activities and the learner, the student has to decide which one is doing work and how much. Sometimes you're comparing 2 situations and there are graphics to help. Sometimes it's just words with a whole bunch of extra variables, and sometimes you have to pull information from a graph. In all of these situations, students need to be able to accurately calculate work in joules. Now let's look at the constructor response section. There are 3 big questions, and if you'll notice, all 3 have to do with work again. So even though Unit 1 is focused on scientific method and work, the only time then that students are going to experience the scientific method is when it relates to work. The first question on the constructed response involves students being able to analyze 3 graphs and synthesize them together. So the analyzing graphs portion of the, or analyzing data portion of the scientific method is utilized in question number 1. In question number 2, they do a little bit more of that experiment setup, like independent, dependent variable, based on a work situation. And the last one is a little bit more of the conclusion writing and calculating work. Let's take a look at the unit plan. So at the very top of our unit plan, for those of you who have never looked at one before, the very top is about the general concepts or the general idea, the feeling you get when you think about this unit. The thing I want you to draw your attention to is at the very bottom, called the statement of inquiry. The statement of inquiry that I wrote is as follows. Humans explore their world to identify relationships and gather evidence to find solutions to community problems. This statement of inquiry could really be for any subject. Exploring our world and determining relationships within our environment is something that we do in all aspects of life. That relation could be cause and effect for war in history, or it could be cause and effect for variables on a graph. In our context, the humans exploring the world to identify relationships is referring to the independent and dependent variables we find in various investigations. So our goal at the end of this unit is for students to internalize that statement of inquiry and recognize that this unit really has a broader scope. Stage 2 of our unit plan has some information about how the students will be assessed on what they learn. For all of the units throughout the 7th grade year, I have written a MYP assessment, like a regular test. However, I also have included projects that students can use to also show what they've learned. Here we see the project. I apologize, it's split between 2 pages. We see the project for Unit 1. This is where students determine the healthiest kind of potato chip by smashing it on a piece of paper and determining which one leaves the largest grease stain behind. They go through all steps of the scientific method independently, and there is also a rubric, which you can't see here, it's technically below this on the unit plan, to grade with. So the MYP grading rubric is also embedded in this document. Stage 3 of the unit plan is more about order of objectives, which you can look at on your own. I've made an easier version of that here. So we can see what you teach in the order that I've chosen to teach it in. Lesson 0 is just introductions. That's where I introduce my classroom procedures and my expectations for things like the scientific interactive notebook. We set that up, we get ready for Unit 1. Some people choose to do a pre-test on this day to get an idea of what their students know already. Some people do all sorts of introduction activities. I have them create a scientist to mirror their likes and dislikes. That activity can be found in the archives from last year. Lesson 1, which is different from last year, is calculating work. I chose to put calculating work at the very beginning of this unit because there's a larger emphasis on calculating work throughout all of the assessments that they'll take for the rest of the year on CAs. So I wanted to start the hardest concept off the bat so that students have plenty of time to do some spiral practice throughout the unit before their first CA. Lesson 2 is when we start the steps of the scientific method. We start with the question. Technically, question should be number 1. Question all the way through conclusions. For every unit, I have a mid-unit quiz that I'll upload, which are very similar to last year's quizzes that you can use to kind of gauge where students are halfway through the unit. If you'll notice down here where it says Lesson 8, which also happens to be around when my sister gets married, there is a written work experiment that I have uploaded, as well as on day 9 a work lab, which is something we did not do last year. At least I did not do this last year. This work lab, and I'll talk maybe a little bit more about it later in this virtual unit plan, but the work lab is where students determine which surface requires the least amount of force to push an object across. So you'll have various different surfaces on your lab tables and have students pull a block of wood or some other material across that table to determine how much force is applied. Since they know distance, they can calculate work as well. This will help both with the steps of the scientific method as well as calculating work and determining what would increase or decrease work. Lesson 10 is the potato chip lab that I mentioned previously. This is the independent lab report that determines how well they've internalized all the parts of the scientific method. This one also has an MYP rubric associated with it. The others above it do not. However, I'd be happy to help you make one if you'd like. Okay, let's move on to common misconceptions of Unit 1. Let's start with talking about work, since that's the first thing or the first topic that is introduced to students. Students frequently have difficulty identifying the upward force in situations. When the boxes are sliding or pushing or moving, students are really good at assuming a horizontal force. However, words like lift or hold, students have a difficult time determining that those words indicate there's an upward force. Otherwise, if they dropped it, it would hit the floor. Again, lots of practice with this concept is really important. Another thing students struggle with is eliminating extra variables. There are usually in work problems things like how long it takes an object to move or how heavy it is, etc. That being the case, a lot of students find the first two numbers and multiply them together without actually thinking about what those numbers are. So it's important to help students slow down their thinking and cross out extra variables so they don't get confused by extra numbers. The next thing I wrote on here is difficulty with reading comprehension. A lot of times when students miss work calculation problems is because they did not understand what the situation was to begin with. I strongly suggest having students draw diagrams and making sure that you use the language that is normally in work problems and problems they practice with. And the ones that I provided online in the archives and this year all have similar wording. Lastly is the importance of spiral practice. All of these misconceptions that I just mentioned up here, upward force, eliminating extra variables, and difficulty with reading comprehension, can be partially solved by spiral practice, spiral meaning an everyday practice situation. That could be in do nows or in homework. The more practice students get with calculating work, the more successful they will be on the CAs that heavily cover that topic. Misconceptions about the scientific investigation design or the scientific method are on the right of the screen. The first one says teaching variables as cause and effect or input and output. Students frequently get the independent and dependent variable confused just as a recall standpoint. So I would spend a lot of time associating the words independent with cause or input and dependent with the words effect or output. Students usually have a firm grasp on the cause and effect relationships in our world. However, associating the words independent and dependent can cause a struggle. So starting with cause and effect is very helpful. Next, reading comprehension again is going to be a struggle, especially if you have high population of ELLs in your student population. A lot of practice with this will help as well, as far as diagramming what the question is talking about or diagramming what the experiment is talking about, including graphics alongside experimental design text is very important for those students who learn better when they have a graphic next to it. Students have lots of common graphing mistakes. They need lots of practice determining whether they need to use a bar graph or a line graph. Basically, I tell my students that if it's independent and dependent, they're both numbers, 9 times out of 10 you're going to be making a line graph. So lots of practice determining what kind of graph to make is important, as well as students have a hard time determining what scale to use on the X and the Y axis. Paying close attention to that and giving suggestions is very important. The next is data analysis. Students don't get a lot of practice with this, but it is heavily emphasized on the ACT. So it's important that we start now and give our students lots of opportunities to look at data and come to conclusions based on that data. This is also shown in the constructive response that I showed you earlier. They're going to have to synthesize 3 different data sets. It's very important that we don't make the CA number 1 the first time they do that. The last thing that is difficult for our students in this unit is writing CER conclusions. This is something they will likely do in many of their other classes, so I can strongly recommend collaborating with other people in your grade level team. But giving students lots of sentence starters and lots of examples of good and bad CERs will really help in this area, especially if they're ELL. Moving on. Unit 1 has 3 major labs. Of course, you can add more and you can take away what you wish. However, the ones that I've chosen to do in this unit are the toothbrush lab, the work lab, and the potato chip lab. So I'm going to briefly talk about all 3. The first one is the toothbrush lab that I use to help students identify when there's more than one independent variable in a situation, as well as helping them write very specific detailed procedures. Essentially, I give students 2 different kinds of toothbrushes and a comb. The comb represents the teeth, and I put marshmallow paste on the teeth so that students can set up or design their own experiment to determine which toothbrush is best. Students make lots and lots of mistakes along the way when they design this experiment, and I use that as an opportunity and a teachable moment to show them that how important procedure writing specificity is, as well as having only one manipulated variable. The second lab, which is near the end, is the work lab, and I briefly talked about that earlier, where students have various surfaces. Could be a table with a towel on it, or sandpaper, or construction paper, any surfaces that you prefer. And students pull a object across the surface to determine which surface allows for the least amount of force, and then in turn the least amount of work in joules. This is a good practice for their CA. And the very last one I also mentioned, the potato chip lab, is where they look at various types of potato chips as the independent variable and determine which one is healthiest, the dependent variable. I strongly suggest using veggie chips for this because it is very interesting when students realize that veggie chips actually have more grease than they anticipated. It also helps you show what it looks like to write a conclusion when your hypothesis is wrong or unsupported. The last thing I wanted to talk about was Unit 1 end goals. What should students know by the end of this unit? And really it boils down to two things. They need to be able to write a clear lab report, and they need to be able to calculate work in any situation, whether it's pictures or graphs or just words. So if anything, at the end of this unit, students need to be able to write a lab report and calculate work. If you have any further questions about this unit or you'd like help with your lesson plans, please don't hesitate to reach out. Again, my name is Ann Lawrence, and I'm the 7th grade CTL. Thank you for watching.